Hello, welcome back. And in this week PowerPoint, we will talk about wiring the Honeywell R7795. It's a very common control for industrial boilers. We have few of those in the shop, and I'll have you try to wire those on the boards before you can look at them and wire them on a real boiler. It's made by Honeywell, and we have to locate the board location that goes with that control, and also be aware of the tools you need to use for this control. Probably you use the, the banana connection. They call the banana plugs connection to connect those on the boards. And I would like to have you use a team of 3 because it's a very involved wiring, and I want you to have somebody to double check your work as well. So we'll get familiar with the sequence of operation, and if you have noticed, the sequence of operation is always going to be the same. So once you wire one of those controls, you kind of have an idea of how the other ones should function. Wiring, again, most of the terminals, most of those control are wired to a base. The base is completely wired, and you have the terminal outside to connect with your other components. Again, we would like to minimize the wiring and unwiring of the control, and that's why usually these controls come with a base, and the control actually connects to that base. Again, same different sequence of operation all the time, so you have to be aware of that sequence of operation that can change based on the cartridge that you have inside. So let's look at the control and the other component that goes with it. So usually the control will be located in this box over here, protected from the other elements, and again, it does look like a lot like our regular residential burner, but it's a little bit bigger. This here, if you notice, this is called the modulating cam. There's a lever that goes from a damper, a small motor that will turn left and right, and these linkages here will control the air damper and the fuel based on the firing rate required. So we'll look inside the MOD, which is the modulating motor. So the MOD is connected to mechanical linkage. I showed you that. It will open and close the valve and also the air damper gradually to change the pressure and the fuel ratio. It provides proportional control. It's preset, and we can do the mixture by opening the modulating control for the ratio where those linkages are connected and where they intersect inside the modulating control. And again, this is kind of still, it's old, but it's still functioning. But in newer models, probably you'll have electronic control for the air and fuel ratio. As we said, it's called parallel. So this is what's inside the MDM, which is the modulation control. So if we look here, we have a cam. We talked in the classroom about the cam. What does the cam do? It's a timing function using gear. So those times will connect. There's a small transformer here that powers a small motor that will turn the cams left and right to provide this interconnection between the linkages in here and here. So this is a low fire cam and a high fire cam, so you can turn the lever based on the request of high fire or low fire. This is the board, and this is how those cams will control using the lever inside the modulating. So again, the Honeywell, it's a very common control. I think it's still being used for models that has since the beginning, because changing one control will have you change a lot of components, and again, the approval for those controls takes a long time. So each one of those control has to be approved by underwriter. So these are the model here and what flame detection system goes with it. Again, ultraviolet goes with gas and fuel for this one. Don't generalize. Every one of those components or scanners are different, and these goes with, you can use either of these models if you want to use ultraviolet. If you have a rectification system, which is a PV and a flame rod, you have to use This model I will go with it, and you also have to go and check the uh, cartridge and the program that goes inside the control. If you will there's a purple paper that can be used with either gas, oil, and coal, and this is the only one that you can use if you have coal. There are some people who still use coal. Electrical rating, again, just like we did before. Notice please, for the voltage it has to be plus 10 and minus 15% of that 120 that's required VAC, and this is the frequency 50 to 60 hertz, so it can't take 50 hertz. And different models with different watts. So this is again watt, how much power does it use? 17 watts, 15 watts, not that much. And these are the terminals and how much power goes through it. It's very important to know what is the watts, because that will help you know what is the resistance and also what is the amperage. So if you would like to check the amperage draw, you can kind of predict what goes into it. Main fuel valve, fan and burner motors, and finally the alarm, which is very small, around 1 amp. So alarm can be, again, as I said, either light or a sound alarm or connection to a bigger components. This is the board. The board is already been connected, and the control goes on the board. And again, we have another set of connection here we can change, and the pre-purge timer that also can be changed. And the main control is inside here and it's covered, so you cannot get to it. There's only one reset button from the front, and it allows you to reset only. Here is the sequence of operation to follow the timing. So the pre-purge, throttle ignition, and normal run. So what will stay on the whole time? So the burner blower motor will start from the beginning till the end. Ignition will go only in the second stage. If you have interrupted pilot valve, will stay until we run, until the fuel valve comes. So it's really a nice way to look at the sequence of operation. Limits will always going to be on, and the airflow switch, since the pre-purges start, and in the beginning we have a safety check, and finally flame proving. So this is where we start: limits, burner motor, and safety check, and it goes on. And at the end you'll have 4 things running: the burner motor, main fuel valve, limit should be still on, an airflow switch, and flame. So those signals should be always on when we turn on the connection from the each terminals, as we said. Number 5, and this is for gas. I don't know if it doesn't say whether it's gas or oil. I'm going to assume it's gas. Pilot, main fuel, transformer, flame detection is FG this time, not FF. I'm going to ask you that in the quiz to check that it's not FF, it's FG. Burner motor, line voltage, limits, and controllers. So again, these things will stay, and make sure you get that part correctly, which is 7 goes back to 3. We'll look at that when we do the wiring again. That's what we're going to see inside the control. This is the pre-purge time again, that can be changed. Safety switch, and look at this little connection. This is for the flame testing. You can add a flame tester and connect it to this jack over here. So these jumper you can clip if you want to change the 4-second trial to something else. But again, check with the manual and check with the boiler conditions and see if that's okay or not. And this is the flame indicator LED, which should come up in the light. You'll see the light. If the flame detector is working, you will see that light comes up. And let's see, yellow jumper clip if lockout on loss of flame is required. So these are conditional control that we can do. And you can see this whole thing actually can be replaced with whatever controls and pre-purge timing that you need. So again, when we do that on the board, please check before repowering. Make sure the connections are in the right place, and check for continuity, and make sure all the pressure switches and safety switches are connected in series, not in parallel.